I will make a series of videos about our power system because this is a complex subject and you rely on the power, of course, in the motorhome for your water pump, to your computer, lights, sometimes heating or cooking, fridge, and so forth. That's why I want to make a series of videos to explain our really crazy power system because it's a power system that I have not seen anywhere else, to be honest, and it ended up so Frankenstein and so unique, I would say, and useful in a way, because I made several mistakes and I learned from those mistakes. And I want to explain to you, whoever you are, if you are interested in doing this for your motorhome or your little house somewhere. It's almost like doing this for my past self, where I needed some help, but sometimes I didn't get that much help from the videos that I've seen and the articles that I've read because people try to explain it, I think, in a quite a complicated way. So, here's the thing about the power. Before we bought the motorhome, I was thinking, okay, how much power do we consume so that I know what kind of batteries to buy? And honestly, this is really not that reliable. But I'll give you an idea. So, first thing you have to keep in mind, the word watts. That W that you see on the back of pretty much any electronic. Okay. For example, I have here. This is a small electric heater, and you may not see it in the video, but here it says 2000 W. That means it's 2000 watts. What does that mean? It consumes 2000 watts in 1 hour. So that's important, 2000 watts in 1 hour. Okay. This is an extreme example. Like this consumes a lot because it's a heater. My laptop, for example, if it's fully charged and is plugged in, consumes around 30 to 50 watts an hour. How can you know? Sometimes you can look in the settings if you have Linux, for example, on your laptop, or you can buy some power plugs that show you the power consumption of whatever you plug into those power plugs. Before you move in a motorhome, maybe just get an idea. That's what I did. Kind of, I was calculating. I was like, okay, so is my laptop is like 50 watts an hour. Such as laptop, maybe 20, 30 watts an hour. Charging some of this electronics that we have, that's a bit difficult. Like, how about the toothbrush? These are negligible, to be honest. Let's say we consume 1 kilowatt a day, meaning 1000 watts. That was my rough calculation after I looked at all kinds of electronics that we had. So I said, okay, let's buy a 1000 watts battery, because a 1000 watts battery holds 1000 watts, right? And then if you consume 1000 watts in a day, maybe you'll consume that battery in a day. Maybe that was a good start. I was wrong, but anyway, just to give you an idea, that W is the watts is the most important part if you want to understand how much power you need. Okay, next step. This watts is made out of two things, and these are crucial if you really want to understand the power system and you want to build one or make a custom one, or just to have a complete idea, a complete basic idea about what power means. Watts is composed of volts and amps. Volts and amps. Look at these two power sources. One is the kind that you see in a car, that cigarette lighter or however you call it, and the other one, it looks like the ones that you have at home. So the one that it looks like a car charger, it's 12 volts, and the other one in Europe is 230 volts. Why is this important? Because these are two different systems that you will have in a motorhome. Don't panic about it, it's quite easy to understand. The 12 volts basically means that it's like for low powered devices, and the 230 volts is for whatever else, like for example, this is for phones, of course, or whatever, USB A here, and you can plug whatever. You can be a phone, you can charge a power bank, whatever. Sometimes laptops with bigger ones. The truth is that you can take that power cord and plug it directly into a USB socket in that cigarette lighter. Okay, and that is direct current, like DC. This is direct current, 12 volts. So it's like very low power, very efficient. The reason that you see this brick is because it tries to convert the DC power into AC. So you can also plug this into that 230 volts. So basically you can charge your phone either more like efficiently to that cigarette lighter, whatever, or a bit more inefficiently and use this kind of converter, basically like this power brick, to charge your phone from AC. In a motorhome, for example, you will see a battery, okay, this big battery. The battery that's inside the motorhome, the habitation battery, okay, the house battery, however you call it, that has a positive and a negative. And that battery is normally 12 volts. It says on it 12 volts. It's interesting to know that you can take a cable directly to put it to the positive and onto the negative, and basically you can plug the other ones in the end of the light bulb and a LED light, for example, and have power, directly from the battery. It's like 12 volts, and it powers the light. You can do the same with a water pump, for example. In the motorhome is 12 volts. So there are 12 volts devices, basically, like a light, a water pump, there are fans. Now, like I said before, watts is composed of volts and amps, and you have to multiply them to see the wattage. If you want to have more power to charge, for example, an electric heater that is 2000 watts, this is not possible to connect directly to the battery, because again, think about it. The battery gives you, even if that was possible to connect directly, which is not, because this works differently, AC current, not DC. But if you were to connect, you only get 12 volts. Remember, 12 volts from the battery. So for that, you need an inverter, and we have an inverter for our battery. An inverter, all it does is connects to the battery and transforms these 12 volts in 230 volts. And these inverters usually come with a power plug at the other end. So it's as simple as like almost like you plugging into like a power socket. You plug let's say a power cord with multiple plugs, and that's all it is. Then that's your power system in the motorhome, right? So now to take a clear example, to fully understand the relationship between watts, volts, and amps, this small power heater, like we said, it consumes 2000 watts. And if you look at the back here, it's designed, if you see a power plug like this and you are in Europe, you know that this is 230 volts. It's not 12 volts. So we know, okay, it's like the power plug like at home. This is 230 volts and it consumes 2000 watts. How do we know how many amps? Well, you divide 2000 watts by 230 volts and you get less than 10 amps. Okay, and this is important. Why do you need to know the amps? If you are to build your own system like I built, it is crucial to know especially the amps. Why? I'll show you now. For example, I have this power cord that is cut, and you have this kind of wires all the time. When you cut a power cord, you have the positive, which is usually red or brown. You have the negative, which is usually blue or black, and you have the ground, which is like double color, like yellow and green, for example. If I want to make a longer cable for this, so I can plug into it. So I have the cable from the heater. I want to plug it into this maybe, and this I want to extend with another cable, like so. Whenever you do these kind of connections, for whatever reasons, and you will do them for, I don't know, from doing it for your rear camera to whatever other things you have in the motorhome, you will end up doing all kinds of connections, like putting wires between batteries, putting wires from the battery to the inverter, to the solar controller, to whatever. You have to choose the wires really, really carefully, because this is the main source of problem. This probably takes in from the battery around 10 amps, less than 10 amps. If I put a cable like this somehow in the connection that is not geared for more than 10 amps, you will make the wire hot and you will melt and you will create a lot of problems. That's why You need to choose the size of the wire accordingly. If you look at our batteries, how they are connected between them, you see very, very thick wires, because those batteries are 12 volts, but they can push to that 12 volts, they can push between the batteries like 50 to 100 amps. 50 to 100 amps, that's just enormous amount of amps. And there is a chart that I always use, and I'm putting it on screen now. And in this chart, you can see exactly what kind of wire do you need. Let's take again the example of the heater. We know that if I want to put a bigger cable on this one, I need a wire that can support up to 10 amps. So no, not lower than 10 amps. Let's just get safer. Let's say 10 amps. And I go here at this chart. I'm like, okay, look, I have 10 amps here on top, and my cable, I want it to be like over 3 meters, around 3 meters long. So I see this on the chart that I need a 14 14 AWG. I don't know how you pronounce this. A cable that is 14 AWG is so important, this chart. And you may think, what is this 14 AWG? Well, you want to buy a cable, just go search online, 3 meters 14 AWG cable, and that's it. And you buy a 3 meter 14 AWG cable, and you know that you are safe. It can push 10 amps without a problem, and that is extremely crucial. I use this chart all the time because, for example, we have a solar controller, and the solar controller can push up to 50 amps to the battery, and the solar controller does not come with wires. So I said, okay, so it pushes 50 amps, and I need maybe just less than a meter or 2 meters. So I see here that this 6 AWG type of cable, this thickness, covers up to 4.6 meters. So I was like, okay, I'm safe. I can get a 6 AWG cable, and if I don't use a cable that's longer than 4.6 meters or whatever, then I'm fine. So that's what I did. I said, okay, I searched online, 6 AWG cable. I bought one for like 2 meters, and that's how I made the connections. And now I'm safe because I know that this cable can handle up to 50 amps without a problem. The next thing that you have to consider is, usually when you connect cables, you use this kind of connectors, and these connectors, like the wires, should also be suited. We have a bunch of such connectors, and you can look at the back of them. You will not see here, but in the camera, but it says 10 amps here. It means that you can push 10 amps through this. So it's, again, this connection may look small, but it can handle no problem this heater. Last thing, if you want to make a safe connection, in general, you don't just connect the cables. Sometimes you have to put a fuse or a circuit breaker. What happens if there is a loose connection or a battery that for some reason it breaks or whatever, and it pushes too much power, or some cables touch and it pushes too many amps through the wire, and then you can melt everything, the wire, you can fuck up your devices and so forth. That's why you have to put some fuses or circuit breakers. For example, this is a wire that is interrupted here with this little green thing. I took this out. This is the fuse, and now basically this cable is interrupted because here it will only be connected if you put this. This one it's just a piece of metal inside, as you can see, and in between this is the connection between these two parts. So in order to connect this wire with this other wire, you put this here, and the connection is made. And for example, we have charger that goes from outside. So if we go to a campsite or whatever, motorhome parking, we can plug into their power system and they push power into our motorhome. But in the motorhome, I put a fuse. So lots of power will come through the wire. And I calculated and I said, okay, it can put up maximum 16 amps, because you can look at the campsites and be like, what's the maximum amps that it can put, because amps is important to keep in mind. And maximum is 16 amps, So I said, okay, I will interrupt the positive cable because that's the important one. No, don't interrupt the negative cable. I'll interrupt it with the fuse like this, the positive cable, and I put inside of it a 15, in this case, 15 amps. If I had 16, I would have put 16, but I put 15 amps fuse, which means the all of my system in the motorhome, it's okay for 16 amps maximum. But if something comes from outside for some reason and I try to push like fucking 20 or 30 amps, then it will melt this connection. That's a fuse, that's what it does. It will melt this connection between these two wires. It will break this connection, poof, and inside it will interrupt the wire. So all of the current will come, it will not go into the all of the power system that we have in the motorhome. And that's how you protect a wire and then whatever is connected after that wire. And we have a bunch of such fuses or interrupters. We have one from the solar controller to the battery, just in case the solar controller goes nuts or is a short circuit and tries to like kill the battery with a lot of amps. If it goes over 50 or 60 amps, it interrupts the current, so no more. We have this kind of fuses pretty much everywhere for our 12-volt system. We have in the kitchen there, and they're important because, for example, one time it was smelling a bit like burn in the bathroom from the light bulbs, and I was like, what the fuck is happening? And then the power went off in the bathroom. I was like, oh, what happened? And then I look, and it was a fuse in the power box there that melted. And I was like, okay, maybe it was a bad one. I put another one of the same size, and that also melted. And I was like, okay, this is problematic because it was just in the bathroom something happening. And then I take the light bulb out after I turned off the power in the motorhome, and it was some short circuit happening in the light bulb itself. It was this LED light bulb, and it was starting to melt something inside. So luckily I had this fuse that understood basically that is a short circuit somewhere in the system, and that light bulb, it was short circuiting and like trying to get more current, and then the fuse will interrupt that. So the fuse stopped the motorhome from burning down basically, because eventually it will burn down. Something bad will happen if power will come from battery uninterrupted through the wires into this short circuited part of the motorhome. You will melt the wires, you will create maybe a fire. So that's why it's so important to have fuses and breakers and have proper wires. Let's recap, because this is I'm sure the most boring video that I've made so far, but you have to understand these things if you want to deal with the power system in your motorhome. Understand that the W on any electronic device means watts consumed in 1 hour. Look at the back of them, look how much your laptop consumes or other things, and do a rough calculation to see how much power you will need, and based on that, maybe what kind of batteries do you need. And when you see, for example, online batteries like, oh, this is a 12 volt 100 amps battery, meaning like, what the fuck does that mean? Oh, but now you know, right? Volts times amps equals wattage. It means that if it's a 100 amp battery of 12 volts, that's how most are, that's 1200 watts, right? So you understand the relationship between watts and volts and amps. Volts times amps equals watts. That's all you have to know. Okay. In the motorhome, keep in mind you'll have a 12 volt system and a 230 volt system. And now you understand that you can switch from a 12 volt system, so directly from the battery, to a 230 volt system through an inverter. And it matters how much that inverter can put out. You have to look at the watts, be like, okay, this is like 2000 watts, like most people put in the motorhomes, 2000 watts inverter. That's a good inverter because it can even run this heater. And when it comes to wiring stuff, because very likely you will have to wire stuff, it's always important the amps. Keep in mind, amps. The more amps you need, the thicker the wire. 2 amps, you need like this thin wire. 10 amps, 20, 30 amps, you need thick wire. Always get a wire that is suited for the amps, and it's so easy to understand how to get the wire if you use that chart that I'm also linking into this description. Without that chart, I'll have no fucking clue how to make the power system. And of course, the connections between the wires are important to be handling the same amount of amps and a fuse or a circuit breaker, and that's all you have to do. And then you'll realize that if you never did these things, that power cords like you have in the house, like you buy from a store, you know, are nothing more than just some wires, some like this wires like so, that you can always cut and then make a bigger one. You can always cut and be like, okay, I want to connect this with this, right? Like this, and then I make a power cord. And all I do is like connect the positive, negative, and the ground with each other through a proper connector, and that's all it is. And that's how I made all of the wires and the wiring in the entire motorhome, to put all kinds of power sockets, and then to make sure that devices are powered, and they are powered properly based on how much amps they need mostly. Okay, that is the boring part of the video, so you have a basic understanding of the power system and what does it mean, this power. And next time I will show you how we get power from the sun, power from the alternator from the car, or power from outside, some camping sites and so forth, and what batteries we have, and the crazy system that I made, because there are two different systems that can switch between each other. It's for me it's fascinating. So sorry for a very boring video, but you have to have a basic understanding of electricity.